All right, mathletes, here we are looking at the sine rule. So the sine rule principle is developed from looking at the area of the triangle. So notice we can look at the area of this triangle here, or any generic triangle labeled in such way, and we can write the area of the triangle three different ways using the three different angles. One being using angle A, another way using angle B, and the third way using angle C, making sure if you're using angle C, you're using these two included sides to do that. Well, since they're all defining the area of the same triangle three different ways, they're all equal to each other because area is going to be equal no matter how we calculate it. Well, to simplify this, okay, and we divide each expression by 1/2 ABC. Notice on this first part, the 1/2 cancels out, the BC cancels out, and we're left with the A. On the second one, the 1/2 AC cancels out, and we're left with a B. And then the 1/2 AB cancels out, and we're left with the C. So what we end up deriving, and kind of in a simple proof here, what we call the sine rule. Okay, the sine rule says the ratio of our sine of our angle and the angle opposite. So notice that if we're talking about angle A here, the side opposite that is its side A. Angle B here, the side opposite is that angle B, and the side C, angle C here, the side opposite there is angle C. So that we have this proportionality based upon its angle and its opposite side, right? And it should kind of make sense. If we're going to have a small angle of something, it's only going to be able to open up to a small side length. Okay, if you have a big angle here, well, it's going to be proportional to opening up to a larger side length over there. Okay, so let's see on how we can use this principle. Notice you can reciprocate these, so if you just flip them all over, you can use it this way. So either way is going to work. Okay, you just want to make sure if you're dealing with side lengths up top for one ratio, it has to be consistent all the way through. Okay, so let's see our first example is going to be looking and trying to solve for a side. Okay, so with law of sines, I'm always looking for an angle and the side opposite that I know. So that's going to be my proportion that I know. So I'm going to have the sine of 41 over 18. Okay, so since I'm trying to solve for x, I'm looking for the angle that's opposite of that. So this is equal to the sine of 113 over my x. Okay, so now that I have a proportion here, I don't need that third one. I'm only ever going to just deal with two at a time. I don't ever want to try and solve an equation with two equal signs. So now that I am trying to solve for my x here, I'm going to cross multiply here so that I get rid of my denominators. So I'm going to multiply here first. So I get x times sine of 41 degrees is equal to, multiply here, 18 times the sine of 113 degrees. All right, so now since I'm trying to get x by itself, I'm going to pull away this layer. So that's multiplication, so I'm going to divide both sides by sine of 41. Okay, I'm going to divide this by sine of 41. So now that I have this, I have x is equal to, this simplifies to 1. I get x is equal to 18 times the sine of 113 over sine of 41. I'm going to put that in my calculator, and I get 18 times the sine of 113 divided by the sine of 41. And I see that my x is going to be equal to 25 point approximately 3, remembering my units, meters long. Okay, And it should make sense, right? This smaller angle of 41 degrees only opened up to a side of 18, while 113, a larger angle, opens up to a bigger side, 25.3. Okay? So, our next two examples here are going to be looking for angles. When finding angles with law of sines, we have to understand that we're dealing with potentially obtuse or acute triangles. In law of sines, this is true. Okay, so the sine of 180 degrees minus theta is equal to sine of theta. So you can try out different values in your calculator. So as an example, we can see sine of 30 is 0.5. And if we do 180 minus 30, we get 150, and the sine of 150 is also 0.5. And that's true for any sine value and its supplement angle. So sine of 60 ends up being 0.866, and then so 180 minus 60 is 120, and the sine of that is exactly the same. So for these types of problems, not only do we have to solve for our theta, but sometimes it could be a second triangle that we're trying to find, and that angle could be 180 degrees minus theta. Sometimes this is called the ambiguous case for the triangles. Not all the times is there two triangles. Sometimes we're able to reject one of these solutions based upon the information we get. So let's go ahead and look at an example here. So in triangle ABC, AB is 12 centimeters. Okay. AC is 8 centimeters. And angle B, okay, is 28 degrees. Okay, so this is AB, this is 12, AC is 8. Okay, so if I'm going to solve this with the law of sines, okay, I'm going to say I'm looking for that opposite angle in here. So what I'm trying to do is I'm trying to find the measure of angle C. So since side C is over here, that angle is what I'm trying to solve for here, and I know that this side length here is 12. Okay, so using my information I know, I have the sine of 28 degrees divided by 8 is equal to my sine of C over 12. So again, I'm going to cross multiply. So these two first. Okay, get 12 times sine 28 equals 8 times the sine of C. Well, I need to isolate this, so I'm going to divide this side by 8, divide this side by 8. So I get 12 times the sine 28 divided by 8 equals the sine of C. So what I'm going to do is, on the left side, go ahead and get a decimal answer for that. So 12 times the sine of 28 divided by 8, and I get a decimal of 0.7042 is equal to the sine of C. Since I'm trying to find an angle, I'm going to use my inverse. So I do sine inverse of 0.7042, and I get 44.8 degrees. Okay, well, this could be 44.8 degrees for one triangle, but notice, if I do sine of 44.8 degrees, that's equal to 0.7042. I also need to consider 180 minus the angle I got. The angle I got was 44.8. So 180 minus 44.8, we get that theta can also be equal to, or I should say angle C, is also equal to 135.2. Okay? And that's because if we do the sine, of 135.2, we put it into our calculator, we get that same ratio of 70 over 42. So we're not quite sure, so we get two potential cases. One, so if this is C, this is A, and this is B, right? This could be 12, this could be 8. So C can either be 44.8, find the second answer by just subtracting 180 from it, and we end up getting that this angle could also be 135.2. So C is equal to 44.8 or 135.2. We'd need more information to decide which one it is. So at this case, at this point right now, we just say there's two potential triangles and two potential angles for C. Okay, so let's look at one more example here. So here we have LKM is 52 degrees. Okay, LM is 158. Okay, and KM is 128. So again, I'm looking for that angle on the opposite side, so I'm there. So I'm going to try and do law of sines. In my unknown, I'm trying to find the measure of angle L over here. Okay, so if I set this up, I'm going to do the sine of 52 over 158. So the angle on its opposite side is equal to, well, I have 128, and I'm trying to solve for my sine of angle L. Okay, so again, I cross multiply here. So these two, I get 128 times the sine of 52 equals, cross multiply here, 158 times the sine of L. Divide by 158, because I'm trying to get sine of L by itself. Divide by 158, and I get 128 times the sine 52 divided by 158 equals the sine of L. Okay, so left hand side, I'm going to put in my calculator. And I get the decimal of 0.6384. So my ratio of sides, I always like to take those to at least 4 decimal places. And this is equal to the sine of L. So to find my angle, I got to use my inverse sine of 0.6384. Okay, so inverse sine, that answer. Okay, and I'm going to get 39.7 degrees. Okay, well, my second option is if I do 180 minus 39.7. Okay, and I get another answer potentially for angle L is equal to 140.3 degrees. But wait, I already know one other angle. That other angle I know is 52 degrees. If we add 52 degrees to this, okay, it's greater than 180 degrees, and all three angles of a triangle must add up to 180 degrees. So since two angles alone add up to more than that, this is not a potential answer. So the only triangle we get here is, or angle we get in the triangle we get for this has an angle L that is equal to 39.7 degrees. That concludes our notes tonight. Please highlight any questions you might have and bring them to class tomorrow.